Hi, this is Alex from devstories.eu. Langflow, episode 12 of 15. Visual programming gets you 90% of the way there, but inevitably you hit a wall. You need to run proprietary business logic or connect to a custom internal API, and the pre-built nodes simply do not cover it. Extending the engine via Python unlocks that final 10% of absolute control. It is easy to think a custom component is just a standard Python script you drop into a directory. It is not. A custom component requires strict class-level configuration. Without this specific structure, the Langflow engine has no idea how to render your node in the visual editor or how to wire its data into the execution graph. The visual node and the backend logic are tightly bound together. To build a custom component, you always start by subclassing the base component class provided by Langflow. Inside this new class, you do not write a standard initialization method to collect variables. Instead, you define two strict arrays, inputs and outputs. Let us look at a practical scenario. Suppose you are building a custom text analyzer component that calculates word counts and returns a structured data object to the graph. First, you configure the inputs array. You populate this array using specialized input classes provided by Langflow. For the text analyzer, you need a string of text, so you place a text input object into the array and give it a name. This is the part that matters. By declaring a specific input class in your Python code, you are dictating the visual interface. Langflow reads that array and automatically generates a text field on your node in the drag-and-drop editor. If you were to add an integer input object to that same array, the UI would instantly render a number spinner. You define the data requirement in code, and the engine builds the user interface for you. Once the inputs are defined, you configure the outputs array. This explicitly tells the surrounding graph what data type your node will produce. For the text analyzer, we want to pass our result down the chain, so you add a data output object to the array. The output configuration does one more critical thing. It maps the visual output handle to a primary execution method inside your class. You are explicitly telling the engine which Python function to run when the next node requests data. The final step is writing that mapped execution method. This is where your standard Python logic lives. The method automatically receives the values your inputs collected from the UI. You take the incoming text string, split it, and count the words. Then, because the graph expects a standardized format, you wrap your final integer inside a Langflow data object and return it. The structure forces a clean separation. The inputs array builds the interface and collects the data, the execution method processes it, and the outputs array hands it back to the visual graph. That's all for this one. Thanks for listening and keep building.